Hello guys, welcome back to Origin's computer classes. Hope you guys are doing well. Now in today's session, I have brought up a problem from hackerrank, the 3 months preparation kit. That is the maximum perimeter triangle. Okay. Now here our task is to find out the triangle. As from the title of the problem, you can understand our task is to find out the triangle with the maximum perimeter. Fine. Now, the problem is not so easy, but again, also it is not so tough. What we are supposed to do, like, we will be given a sticks array. Okay. Now, from this array, our first job will be to find out a triangle and then from among those triangle find out the one with the maximum perimeter, right? So for finding out the maximum perimeter triangle, so let us first divide the problem to smaller problems. So what is the smaller problem? First we need to find out the triangle, how to find out a triangle from this given array. Now guys, just ask yourself, just pause this video for a second and just uh, write down in the comment section or think of it, how can we find out a triangle, which triplets. See, a triangle consists of three sides, so from this array we need to choose, pick up three such elements which is actually forming a triangle first of all, and then from among them we need to choose the one with the maximum perimeter. Okay, so the first task, let us see how to find out a triangle. So see, there there should be three sides of a triangle ABC. Now A plus B plus C together, it will be forming the perimeter of the triangle. So perimeter, we can say it is the A plus B plus C. Okay, A plus B plus C will be our perimeter. Fine. Because the perimeter, as we know, it is a common sense, the sum of three sides of a triangle, that we all know. But the logic to find out the triangle is, we should pick up three sides in such a way that it should fulfill all these three conditions. Like say, suppose I am having a triangle of side ABC. Okay, ABC. Now for that triangle, A plus B should be greater than C. Fine. Like say, we can take this example of the hacker rank itself. They have found out these two triangles, 2 3 4 and 3 4 5. Now A plus B should be greater than C first of all. So here 2 plus 3, 5 is greater than 4. Fine. Okay. Now that is not all. B plus C should also be greater than A. Means that whenever we add two sides, any random two sides of the triangle, it should always be greater than the third side, right? So then it is a valid triangle. So say in this case also, so if we add 2 plus 3, that is 5 greater than 4, 3 plus 4, these are another two sides, so 7, is 7 greater than the third side, that is 2? Yes. And also 2 plus 4, that is 6, 6 is greater than the third side, that is 3. So the three conditions here are fulfilled: A plus B greater than C, B plus C greater than A, and also C plus A greater than B. Sorry, this is a typing mistake. C plus A must be greater than B. Fine. So this is these are the three conditions for which we can say the triangle is valid. If a triplet from the chooser from the array, a triplet which we are choosing from the given array, if it satisfies all the three conditions, then it forms a triangle first of all. Fine. Now, from among these triangles, we have to choose the one with the maximum parameter. Like say, if in this case, 2, 3, 4, 2, 3, 4 is having a perimeter of what? 2 plus 3 is 5, 5 plus 4 is 9. And here it is 3 plus 4, 7, 7 plus 5, it is 12. So among 9 and 12, 12 is greater, hence we take the 12. So our task here is we should find out the maximum perimeter, and also along with that we need to return the maximum perimeter, and along with that, actually not along with that, we need to find out the maximum perimeter and return that triplet only, which is actually giving us the maximum perimeter. Now, this is quite easy, right? Up to this is quite easy because we can just randomly start a loop and actually just figure out. Say, suppose we start a I from here, then if I, wherever I is standing, and I plus 1 and I plus 2, so this we will be checking the three conditions, that if sticks of I is less than sticks of I plus 1 and I plus 2, right? I mean, sorry, greater than. If it is not, then it is not a triangle, and so we can check and return. Ultimately, we can do the sum of the triangles and return the perimeter. So there, up to that, that is not a big deal. But the big deal here is, this is not all. See, first we need to find out. We need to find out the maximum perimeter first of all. Now, if the maximum perimeter is found, say in these three examples, like say here six, among these 616, 658, 584, 616 was a valid triangle, so it is forming 13. 658 is also a valid triangle. If you do, say 6 plus 5 is 11, 8 plus 5 30, 6 plus 5 11 greater than 8. Okay, 8 plus 5 13 greater than 6, and 6 plus 8 14 greater than 5. So it is forming a valid triangle and maximum perimeter is 19. Similarly, 5, 8, 4, 17 and 20. So we choose the maximum one, that is 20. Now here they are only returning, actually these examples are taken from Geeks for Geeks. Okay, so they are just returning the maximum perimeter, but in hacker rank we have to return this 668 also. Okay, this 668, this triplet also we need to return. And now let us see this example, the last one. This is an arbitrary example I have taken. Not okay. Now here in this example, what are the triplets that are forming the triangle? Let us check. Let us choose first of all 9, 12, and 15. Okay, 9, 12, and 15. Now 9, 12, 15. Is it forming a triangle? Is it forming a triangle? Yes, because see 9 plus 12, it is 21. 21 greater than 15. Yes, that is true. 12 plus 15, 27. 27 greater than 9. Yes, that is also true. And 9 plus 15, 24. 24 greater than 12. That is also true. So what is the perimeter of this triangle? So it is 21 plus 15, 36. 36 is the perimeter of this triangle. Can we form any another triangle using this array? 12, 15, 10. 12, 15, 10. It is 27 27 greater than 10. Okay, fine. 32 greater than 15. Sorry, 12 plus 10, 22 greater than 15. Fine. And 15 plus 10, 25. Okay. 25 greater. So this is also forming a triangle. So 12, 12, 15, 10. Okay. And what is the perimeter of this triangle? It is 37. Okay. 15, 10, 10. So 15 plus 10, that is 25 greater than 10. Okay, fine. 15 plus 10, 25 greater than 10, fine. 10 plus 10, 20 greater than 15. That is also, so 15, 10, 10 also forms a triangle. Okay. By the way, this is an isosceles triangle because two sides are equal. So fine. So 20 plus 15, That is, it is forming a perimeter of 35. Till now, the maximum perimeter is 36. Okay, let us check. Last one is 10, 10, 16. Is it forming a valid triangle? First of all, 10 plus 16, 26, greater than 10. Okay, fine. 10 plus 10, 20, greater than 16, fine. And this is 10 plus 16, 26, greater than 10, fine. So 10, 10, and 16. It is a valid triangle, and what is its perimeter? 36. Now, here there is a conflict. So we are having 36 as the perimeter for this triplet and 36 as the perimeter for this triplet also, right? Which now, according to the problem, which one we are supposed to return? So, see, first of all, choose the triangle with the maximum perimeter. Fine. Now, if there are several valid triangles having the maximum perimeter, choose the one with the longest maximum side. Choose the one with the longest maximum side. So here, if we compare from among these two, in this triplet, what is the maximum side? 15, right? So 15 is the maximum side. And in this triplet, what is the maximum side? 16. Okay. So we should return this 10, 10, 16, because choose the one with the longest maximum side. So here maximum side 15, here maximum side is 16. So 16 greater than 15. Therefore, this is the triplet we should return in case of this. If the sticks array is like this, 9, 12, 15. Got it. I hope you got the problem by now. Fine. And then also, even if in other cases, even if also if more than one has that maximum as well, choose from them with the longest minimum side. Okay, now see, if there is another triangle which is having, they are saying like here the longest maximum side was different and we chose the one with the greater one. Now there can be another case where say the longest maximum side is also same. Okay, in that case, we need to check the minimum one with the minimum one. So here the minimum side is 9, here the minimum side is 10. Okay, so again also if we look at the minimum side, also the longest minimum side is this one only. So as per that also we should return this. Fine. So these are the three conditions we need to check. First of all, so let us now start solving the problem. Okay. Now, for one approach is how can we solve this problem? First of all, the steps are we need to find out the triangles. First of all, so step one is to find out the triangles. Okay. So one such triplet which form the triangles. Okay. Triangles. Okay, sorry, triplets forming triangles to be found, right? And then one with the maximum perimeter. Now, tell me one thing. Say, suppose here, every pair, if we take the last example, here every pair was forming a triangle. Okay. Now, let us check by see, one approach is what we can do. We can just use a nested loop. We can travel this whole array and we can choose the one which is forming the triplet, one which is the triplets which are forming a triangle. Okay, and then again use a j loop, so one loop inside another loop. So one will be traveling this entire array and check which triplet is forming a triangle, and then inside that we can use another loop which will be finding out the triangle which one with the maximum perimeter, right? So that is a bit again be a big of n square time complexity. Okay, fine. big O of n square time complexity. And also the problem will become complex because we need to find out not only the maximum perimeter, okay, not only the maximum perimeter, but again, if say suppose more than one triangle, triangle having the its maximum perimeter, we need to find out the long one with the longest side. And again, if it is also same, then we need to find the minimums. Now, all these things can be resolved. Let's say if we sort the array, isn't it? See, any standard sorting technique here we can use because see the value of n here is it is 3 less than equal to n less than 50. So if we take say suppose any standard sorting technique, that is say suppose bubble sort also, if we take bubble sort or selection sort, at max it can take big O of n square time complexity, that is 15 to 50 2500 iterations. So it is quite possible, not a big thing. But after sorting, our problem will become easy. Say once we sort the array, once we sort the array, let us see. Let us take this last example only. Once we sort the array, say it is first it comes here 9 only, then 10, then again 10, then 12, then 15, then 16. Fine. Okay. Now, so now what can we do? So 9, 12, sorry, 9, 10, 10, then 12, then 15, then 16. Fine. So now we can actually use the same approach. We will just require one loop to travel this array. Just we will be checking whether this 16, now just start checking the triplets after sorting. From the reverse side we will be traveling, that is from the last element. So 16, 15, 12, is it forming a valid triangle? I think so, because actually say 12 plus 16, it is 28. 15 plus 16, it is 31. Okay, and 15 plus 12, it is 27. So 27 greater than 16, 31 greater than 12, and 28 greater than 15. But is it giving us the maximum perimeter? Let us see. 12 plus 15 plus 16. Okay, so it is 31. 16 plus 15. Okay, let me check once. I think this is the maximum perimeter in this case actually, because 36 is one example I have taken. Very sorry guys, actually 30 this is the maximum perimeter. What is it forming? 12 plus 15, 27. 27 plus 16, it is 43 actually. So 43 it should return. Sorry. Here actually we are quite lucky that we are actually getting 43 now after sorting. So see, after sorting, actually the problem became easier. Here also we could have found out that, because see 12, 15, 16 also another triplet possible. Right? So 43. But say suppose here we didn't have this 12, 15, 16. Okay. Say suppose 12 and 15 was not present. Let us take this part. Let us take this part only. Say suppose here from here also I am removing this part. 12 and 15 I am removing. Okay. 12 and 15 I am removing. Okay. And let us suppose, so say 10, 10, 16 it is forming 36. And we can take some other example. Say suppose what can we take? Before this, we can take other examples. 6, okay, 10 plus 10, it is 20, and 16, it is forming. Okay, let us just form some other examples. Say suppose these are the true triplets. Okay, so 10, 10, 16. in this case, like we were lucky, so we got 43 only one as one output. Okay, but say suppose 36 was our perimeter, largest perimeter. In that case, we would have got this one, 10, 10, and 16. Fine. So not to worry, guys. In this case, say suppose I remove 12, 15. In that case, we are left with only 10, 10, and 16. That is 36. Fine. And also say suppose here you can take other values like, okay, so let us take here another one. Say suppose instead of 12 and 15 we are going to have another one. Say suppose here I am having 10. Okay, say suppose here I am having 10 again. Fine. And here say suppose I am having at the end of the array 17. Okay, and now the array is completely sorted. Okay, now just consider these two triplets. So we can have 20, say 10 plus 10, 20 plus 16, that is 36. Yeah, fine. And 10, 16, 17, is it forming a valid pair? Yeah, it is forming a valid pair. Okay. And so again, actually that is forming 43, but say suppose 10, 10, 16 and 9, 10, 17. From among here, which one to choose? So we are supposed to choose the one with the maximum longer side. Now, while traveling from the back side, see the maximum longer side we will be obviously getting because the complete array is sorted and we will be choosing the triplets like what can we say? First triplet is I minus 1, sticks of I minus 1 once the array is sorted, sticks of I minus 2, and stakes of I minus 3, right? So see I minus 1, 17, 16, and 10. So 10 is by default here the maximum longer side. Here actually the maximum, sorry, maximum minimum side. Fine. Even if we want to get the maximum longer side, say 9, 10, 10, and 10, 16, 17, right? So 9, 10, 10, it is forming a valid pair because 19, 20, and again 19. So it is a forming a valid triangle. So 10 and 17. So 17 is larger. So this one is by default chosen. Once we actually just we need to check the last triplet here. If it is, say, if the triplet is forming a valid triangle, so our algorithm will be like we are going to first sort the array. Okay, first we are going to sort the array. So let us use this sorting technique. Let us say we are using sort the array, bubble sort technique we are going to use. Sort the array. So for what is the bubble sort technique? For int I is equal to 0, I less than n, okay, I plus plus, opening brace. Okay, so what is n here? We need to, instead of n, we can take here sticks count, okay, because sticks count is the, they have mentioned here sticks count is the size of the array. Okay, sticks count, obviously this is understood. So sticks count is the size of the array, sticks count. Okay, and then we are supposed to start for j is equal to 0. Okay, for j is equal to 0, j less than, okay, actually we can use it like Okay, so we can just simply iterate over the array. I hope you know the bubble sort technique by now because I have discussed it in my previous videos. So j is equal to 0, j less than sticks count minus, because see, instead of n we are using here sticks count. So sticks count minus I minus 1. Okay, then j plus plus. Fine. And here also actually not till the end. It is actually sticks count minus 1. Fine. Sticks count minus 1 because 1 n minus 2 actually. So okay. So I less than sticks count minus 1. Okay, fine. If see, this is an array dynamically allocated. If we see the main function, they have actually dynamically allocated the sticks count array. So what we are supposed to do, how we're going to access the elements in case of dynamic memory allocation, I have already discussed in my dynamic memory allocation lecture. So please watch that lecture. It will be helpful for you because I am not going to discuss it in this video because this problem needs to be solved. Okay. So go just before watching this video, once go and watch my lecture on dynamic memory allocation. It will be clear. So how can we access it actually? So value at sticks. Okay, value at sticks. See, it is sticks is allocated dynamically malloc n into size of. Okay, so sticks plus I. Okay, greater than value at sticks plus j. Then let us swap int temp is equal to value at. Let me just copy paste it because it if I start writing again and again it will be taking time. So sticks plus I, if sticks plus I is greater than value at 6 plus I, and again just if value at sticks plus I is equal to value at sticks plus j. See, it is just I'm explaining this instead of, because in case of static allocation we would have written sticks of I. But since it is dynamically allocated, because it is returning me a pointer, right? So I need to actually use that pointer to find the value at that memory address. Okay? So this is the hint I'm giving. So sticks is providing me the base address of the sticks array, and then I'm using I of the increment to go to my specific address wherever the value is. So that is actually the ith index, right? Okay, so sticks plus j is equal to temp, right? That's all about the sorting of the array. Okay, fine. Now, just what can we do? Let us travel the array from the reverse side. Travel the array from the reverse side, right? And we need to return an array. We need to actually return the triplet which we are getting. So let us also create an array because see here they have given a result count, right? So what is going to be the size of our resulting array? It will be 3 actually only. It will be 3 only. So let us take an array, say suppose int result is equal to malloc size of int, okay, into 3 3 only, because we are going to take 3 sides only for triangle, so obviously 3. Here we will be actually just allocating the size, and we need to return the result in the form of array only, the triplets, because they are asking here to return a int of 3 size array. Fine. Hence, so first let us travel the sticks array from the reverse side. So from the reverse side means from I is equal to n minus sticks count minus 1, sorry, sticks count minus 1. Now t up to where the I will be traveling. See, if I travel, see, it is quite possible that the last element doesn't form a valid triangle. In that case, I need to travel till the third index, index 2. Because if I travel till index 0, if I is equal to 0, then sticks of I minus 1. So that is minus 1, and minus 1 is out of bound. Right? Hence, I need to travel up to this index. So here it is index 2. So sticks of I actually, here we are going to consider sticks of I minus 1 and I minus 2. Okay. I minus 1 and I minus 2. I minus 1 and I minus 2. Okay. So I, so we need to travel up to the index 2. Index 2. Okay. So I greater than equal to 2 and I minus minus. Fine. In. Okay. Now, so let us take the three sides. So int a is equal to sticks of value at sticks of sticks plus I. Okay, fine. So let me just copy it here. Mm, wait, let me just copy and paste it here so that it will be easier for you. So control C and okay. So int b is equal to sticks plus I minus 1 and int c is equal to value at sticks plus I minus 2. Fine. So when is it going to form a valid triangle? So checking if it forms a valid triangle, right? Checking if it forms a, just so if checking if it forms a valid triangle. So when will it be a valid triangle? Guys, when will it be a valid triangle? So it has to be like, see, as we are checking the last part only, see, otherwise, other than this, automatically, see, only one thing, a plus b has to be greater than c. See, other conditions also we can check. That is a plus b greater than c, then b plus c greater than a, and c plus b greater than, sorry, b plus c greater than a, and c plus b also greater than a. Okay. So if we do that, see, already the array is sorted. So, guys, do we need to actually check all these three conditions? No, right? Because see, already the array is sorted. So, isn't it enough if two minimum sides, that is 10 plus 16 here, it is greater than 17, because 17 is the maximum side. So, if two minimum sides adding to minimum sides are greater than the 17, then obviously these are also going to form the triplets. Okay, these are obviously the all the other conditions will be true when the array is sorted, right? Because say if we add 16 plus 17 when the array is sorted, if say A, B, C are written where C is greater than B and B is greater than C in a sorted manner, so obviously see A plus B will together form a greater than C, right? When arranged in ascending order. It is a common sense. So we can just check if A plus B, if A plus B is greater than C, then we can return the result array actually, right? So what will be there in the result array? In result plus 0, in result of 0, we are going to have A. Fine. Because we need to also see there is a condition given the lengths of the chosen triangle in non-decreasing, that is ascending order, right? So obviously because A, B, C are already sorted, hence we don't need to worry about that much. So I will be just sending and result plus 1, it is B. Okay, in result plus 2 it will be C. Fine. So return the result. Okay, and here there is one more brace coming. Why is it so? This is one for loop used. Okay, here I am using one for loop. Fine, and this is for the if. Okay, fine. Now otherwise, see if this is true, return the result. Otherwise, if you find, say there can be all it is also possible you find no valid triangle like this one, triangle formation is not possible. In that case they are asking me to return -1. Okay, so in that case, see by default we can allocate that result of 0, result by default we can just say, because we need to return it in the array format, right? So we can just say by default, if nothing is true, if nothing is true, so by default there should be an array which is holding -1. So in the result itself only we can initialize all the values with -1. Say result of 0 is equal to -1. Okay, or we can create, just let me create an array of single size because it will be easier for you to understand, because we need to return it in the form of array. So result, say this race will be returning only -1, having only one value. Fine, and value at race plus 0 is equal to -1. Fine, so that's all about the program, and at the last we return race. Okay, so let us run this code once and check if it is returning the correct result or not. Okay guys, so this was our implementation logic, and say here we have used our result array and allocated it dynamically. See actually here there was a few mistakes. Actually I confused selection sort with bubble sort. This in bubble sort, as we know, see this j should be less than, because see the in bubble sort our objective is to send the largest element to the last part of the array. So as j we just need to compare each two elements in during the pairing. Okay, so that was a mistake. So I hope I have corrected all the mistakes here. Fine. So I am dynamically just checking, allocating the allocation. Okay, and so let's run the code once again. Here it should give the correct output now. Yeah, so it is giving us the correct output. Let us check it with the test cases. Yeah. So it processed successfully with all the test cases. So this is how we could actually reach till the final result. So see, this debugging you need to actually think about the problem, and you need to think what actually you are doing. So then if you know what you are doing, then definitely you will be able to find it how to do. Because see here, sorting was the logic actually. By sorting the array, we could actually do it in one pass only. Now, you may say that sorting takes big O of n square time complexity. So in case of, see here, it was n was less than 50, so we used bubble sort. Bubble sort worked here. In other cases, you can consider quick sort also, okay, and merge sort also, which in average cases a big O of log n time complexity in average cases. And so that's all. If once the sorting is done, so see, this is only just one pass only, right? Just one pass only. Fine. And hence, so we reached till our solution and all these test cases work. Okay. So that was all about today's class. Thank you guys.